Good morning. So let us start question number 51. The element that does not belong to same period of the remaining elements of the modern periodic table. That means the D block chemistry, it is a D block elements. ఈ D block elements లో 8th group important one. That is 8th group in the old system. Also in case of Mendeleev table, it is taken as modern table 8, 9, 10. That's we called transitional triads. Transitional triads. Three elements having similarity in the properties. That's why they placed the previous table, that is the Mendeleev table, 8th group. They are called triads. Now modern table, 8th group is taken as 3 separate groups named as 8, 9, 10. 8, 9, 10. Okay. Starting is 3D series. 3D series, but 4th period. Because this is n minus 1d. ns is the period number, nth value 4. Nth value 4. Iron, cobalt, nickel is called first set of transitional triads. Second set, n is equal to 5. That is called 5th period. Also called 4D series elements. Ruthenium, rhodium, palladium. Ruthenium, rhodium, palladium. Next, n is equal to 6th. 6th period elements, 5D series. Osmium, iridium, platinum. These 6 metals also called one single name given. These 6 metals, that is 4D set of triad, 5D set of triad. These 6 metals also called platinum metals. Platinum metals. Appearance like platinum and properties slightly close towards platinum. That's why they are called platinum metals, but not first set, only the 4D, 5D set of 8, 9, 10 groups or triad groups. Ruthenium, rhodium, palladium, osmium, iridium, platinum are called platinum metals. These 6 only. Next row is last row, 7th period. That's called 6D series. Hafnium, meitnerium, Darmstadtium. But they are synthetic elements. So that is called 8, 9, 10 groups. So that is given here. One of the element not same period. Palladium 4, iridium 6th, that is 6th period. Palladium 5th, osmium, platinum. So osmium, iridium, platinum. Osmium, iridium, platinum. These 3 metals are same period. Palladium different period, that is 5th period. So answer 1. Okay. So triads means 8, 9, 10 groups are called triads. 8, 9, 10 triads because of close resemblance in the properties. Among them, second set and third set, that is 4D set, 5D set are called platinum metals equal to platinum. Okay. Next one, heart treatment of muscular pain involve radiation of wavelength about to 900 nanometers. Which spectral line of hydrogen atom is suitable for this? So, wavelength given, find out energy corresponding to suitable transition to give that much amount of wavelength. So, we know wavelength form directly. 1 by lambda is equal to Rz square into 1 by n1 square minus 1 by n2 square. 1 by lambda equal to Rz square into 1 by n1 square minus 1 by n2 square. Z value 1 because hydrogen. R value given 10 raised to 5. Centimeter inverse, that is important. That is CGS system given. H no need. Direct formula you can apply. 1 by, let us check first in these three. Infinity upper level, lower level corresponding value. I will take first corresponding value 3 square. 1 minute. We do not know first n1 value. n2 value infinity. For these three options, infinity. Okay. So, 1 by lambda is equal to 10 raised to 5. Lambda given. How much lambda given? 900 nanometers. 900 nanometers. 1 nanometer minus 9 meters minus 7 centimeters. So, minus 7 centimeters because this taken centimeters. 1 by n1 square minus 0. So, 10 raised to minus 5. Numerator becomes 10 raised plus 5. Cancel. 1 by 9 is equal to 1 by 9 is equal to 1 by 9 is equal to 1 by n1 square. 1 by 9 equal to 1 by n1 square. 9 means 3 square. 1 by 3 square equal to 1 by n1 square. Therefore, n1 is equal to 3. That means Passion series is the correct one. Okay. So, wavelength given, just to compare the hydrogen spectrum wavelength formula, 1 by lambda equal to Rz square into 1 by n1 square minus 1 by n2 square. R value given simply 10 raised 5 only. That's why get cancelled here in terms of centimeters. 1 nanometer is minus 9 meters equal to minus 7 centimeters. So, that's why minus 5 plus 5 numerator get cancelled. 1 by 9 equal to 1 by n1 square, n1 equal to 3. Okay. So, simple question only, not having much complication here. Right. Next, wrong statement in the following is pH3 shows lower proton affinity. What is first meaning? Proton acceptor. Proton acceptor, proton donor. Follow Bronsted theory concept. Proton donor acid, proton acceptor base. That means it is basic nature. Basic nature. So, pH3 shows lower proton affinity means lower basic nature than ammonia. Correct one? Because ammonia is 3 bond pairs and 1 lone pair. Lone pair disperse or occupy small area because N is more electronegative element. Phosphine same 3 bond pairs, but the bond angle nearly 93 degrees, not pyramid. According to Bent rule or Drago rule. lone pair same, but this lone pair disperse on more area, spread on more area. So the two reasons you will given here. One reason, lone pair occupies, we can give reason for pH3, occupies more area, making unavailable for donation, because the donation means to pair to be given to other molecules. So this is occupying a lone pair, a small area, easily donating, distributing into other protons, because donation of electron pair into proton is called base. Donation of electron pair into carbon center is called nucleophile. So both are same only, but donation of electron pair into carbon center or carbon atom is called nucleophilicity. Donation of electron pair into H plus ion is called basicity. H plus very small size. That is why a lone pair is occupying small area, easily donating into H plus ion. That is why ammonia is a strong base, pH3 weak base. Lone pair occupies more area in pH3, making unavailable for donation into H plus ion or proton. That is one reason. Second reason, that is called Drago rule. Second reason, Drago's rule. Phosphorus atomic number 15, configuration is 3s2 and 3p3. These 3p3 electrons, that is px, py, pz, directly take part in the bond formation without hybridization. Directly bonding. Px, py, pz 90 degrees. That's why this angle is nearly 92.8 due to small repulsion of bond pair. So that is one reason. Second one, lone pair. Lone pair present on the direct s orbital. S orbital, that is 100% S character, pure S orbital. But in case of ammonia, it is sp3 hybrid. S character is equal to 1/4. That is only 25% S character. S character increases, nuclear force increases. Nuclear force increases, donation of electron pair decreases. So that is why 25% S character, 100% S character of lone pair. Lone pair is a little bit free in case of nitrogen atom of ammonia, but not free because of strong force of attraction from the nucleus. That is second reason. Lone pair occupies pure s orbital in pH3. These two are the correct reasons. Both the correct reasons only. So first statement exactly correct one. PF3 exists, but NF5 does not exist. Okay, because nitrogen cannot having vacant d orbital, no d orbital at all. Maximum covalence for nitrogen equal to 4 only. Correct one. Maximum covalency for nitrogen equal to 4 only due to absence of d orbitals. Absence of d orbitals. So this was correct one. Next, NO2 can dimerize easily. Correct one. NO2 dimerize easily. Correct one. Because NO2 is called bent. This angle memorize 134 degrees nearly. NO2. There is odd electron. Means single electron, like radical. So this is NO2 with odd electron. Second NO2, odd electron. These two odd electrons are joined. That comes N2O4. Diamagnetic, because unpaired is paramagnetic, but now pairing takes place by bond formation, N2O for diamagnetic. This is also correct one. Odd electrons undergo dimerization, correct one. But one except very important one in the case of p block elements. So ClO2, same type. ClO2 also contains odd electron, does not undergo dimerization due to large atomic size of chlorine. Odd electron is participated in the resonance to form 3-electron bond. 3-electron bond. Resonance like this. So this is one exception. Never participate in the dimerization. There is no Cl2O4. Remaining odd number of electrons undergoes dimerization. Remaining all of them. Next one. So this statement was correct. Next one. SO2 acts as a oxidizing agent but not reducing agent. This is wrong statement because there are 2 points to explain why it is wrong statement. First, oxidation number. SO2 oxidum plus 4. Plus 4 is in between highest lowest. Highest oxidation number for sulfur. Valence electron 6 plus 6. Lowest oxidation number for sulfur 8 minus 6. So 6 minus 8. Electrons minus 8 minus 2. So lowest value minus 2, highest value plus 6. Highest value always act as an oxidizing agent. Lowest value as a reducing agent. Between them is both oxidizing and reducing agent. Both oxidizing agent and reducing agent between them. So plus 4 between the plus 6 and minus 2. That is why plus 4 acts as both oxidizing agent and reducing agent. But inside one statement is given. SO2 comparison to TeO2. SO2 comparison to TeO2. SO2 has more ability to take one more oxygen to form SO3. Addition of oxygen, oxidation. Process oxidation, compound is called reducing agent. SO2 is called reducing agent. Means strong reducing agent. It is also oxidizing agent, but better one is always strong reducing agent. TeO2 due to large atomic size, it has tendency to lose oxygen. TeO plus O, loss of oxygen, reduction. Process reduction compound is oxidizing agent. Therefore, TeO2 is called oxidizing agent, strong oxidizing agent. This is comparison only, but don't take only one property. SO2, TeO2 both are intermediate oxidation numbers, plus 4 state. Plus 4 state is called in between the higher and lower value, act as both oxidizing and reducing agent. But SO2 is a better reducing agent compared to oxidizing agent. So, statement 4.1 is wrong. SO2 acts oxidizing agent but not reducing. It is a better reducing agent, strong reducing agent. Also acts as weak oxidizing agent. That's why 4th option is incorrect. Okay. Next one, CrOCl3X ammonia can exist as a complex. Okay. 0.1 molality solution of aqueous solution. This complex shows depression of freezing point 0.558. Assuming 100% ionization of complex, so coordination number of chromium is 6 complex will be. Formula. That means one term factor, I factor requirement. Delta TF is equal to depression of freezing point. T0 minus T1 Kf into molality I factor. It had depression given 0.58. 0.558 Kf 1.86 molality 0.1 into I. So 0.558 by 0.186 is equal to I. So I is equal to 3. So this is given 100% ionization. So when 100% ionization given, then I is equal to N. N number of ions. 100% ionization, 1 minus, normally formula 1 minus alpha plus N alpha. I is equal to 1 minus alpha plus N alpha. Now alpha equal to 1. That's why I is equal to N, number of ions. Okay. So 3 particles. 3 particles are 3 ions. So where is 3 ions? Include complex. Complex 1 unit, counter ions respective units. This is 1 plus 3, 4. 1 plus 1, 2. Third option 1 plus 2. This is 1 plus 2 is equal to 3. So answer 3. So this was directly simple question only. Just find out the I factor value. FeO4 2 minus into Fe3 plus 2 volt. Fe3 plus to 2 plus 0.8 volt. Fe2 plus to Fe0 minus 0.5 volt. Series of reaction given. Standard potentials was given volt. Value of E0 for FeO4 to 1, that is ferrite to Fe2 plus. That means this reaction requirement. This reaction is sum of 2 steps. Step 1, step 2. I take, suppose this is first step, this second step. Requirement is third step. So step 3 is equal to 1 plus 2. But EMF is an intensive property. Does not depend on the stoichiometry or number of electrons participate. G0 value extensive property depend on the stoichiometry. That's why calculate E0 value in terms of change in the coefficients or stoichiometry in terms of G0 value, because delta Z0 is equal to minus NF E0. Therefore, delta Z0 of third step, delta Z0 of first step plus delta Z0 of second step minus NFE, F cancel, N number of electrons minus Fe oxidation number plus 6, because FeO4 2 minus x minus 8 is equal to minus 2, x equal to plus 6. Fe3 plus, Fe2 plus. So here N factor is 6 into 2, 4 into E0 value requirement. First step 6 into 3, E0 value 2 plus 1 only, 3 to 2. E0 value 0.82. So, minus 4 E0 minus 6 minus 0.8 minus 6.8 minus cancel. E0 equal to 6.8 by 4, 1.7 volt. Option 1. Okay. So, calculate in terms of delta Z naught value because it is a extensive property depend upon the stoichiometry. But E naught is not extensive, it is an intensive property. So, directly equations cannot be added to find out the E naught value because independent of stoichiometry. Depends on the number of electrons in the reaction. Number of electrons involvement is present in case of delta Z. Okay, 1.7 volt. Next to 56 one, match the following. Schwarz reaction, fluoride formation. Sandmeyer reaction, aryl halides, aryl benzenes and also cyanobenzene. Chloride, bromide and also cyanide. Chloride, bromide and cyanide. Chlorobenzene, bromobenzene and cyanobenzene. Wurtz-Fittig reaction, aliphatic, aromatic. Aliphatic, aromatic, hydrocarbon. Ethyl benzene. Finkelstein iodides. So, A4, B3, C1, D2. A4, B3, C1, D2. Option 3. Okay. Two statements given. Fructose does not contain an aldehyde group, but still reduces Tollen's reagent. Fructose does not contain aldehyde group, but still reduces Tollen's reagent. Meaning is called reducing sugar. Monosaccharides, disaccharides, always reducing sugars, except sucrose. But here example is fructose. Actually ketone, fructose ketone. Then how ketone reduce the Tollen's reagent? Because ketone is a keto group, does not react with the Tollen's reagent. Tollen's only for aldehydes. But the main important step is enolization. Fructose undergoes enolization into glucose or aldehyde. That means keto undergoes enolization into aldehyde. But what is the required condition to form enolation? This is only for Tollen's and failings, but no reaction of Schiff's reagent. Very important one. Fructose does not react. Glucose also does not react with the failing with the Schiff's reagent, because in the corresponding medium of Tollen's reagent, ammonical silver nitrate, alkaline copper sulfate, that is failing solution, basic medium. So, corresponding acidic medium or basic medium, this undergoes enolization. But Schiff's reagent, para-rosanyl hydrochloride, is not in acidic medium or basic medium. That is unable to bring enolization and unable to bring conversion of cyclic form into open chain form in case of Schiff's reagent, because glucose two forms are there, cyclic form and open chain form. Cyclic form is aldehyde group, hemiacetal group, no free aldehyde, that is converting into open chain aldehyde in the corresponding medium. But that conversion possible in the required amount of medium, acidic medium or basic medium, but not possible in case of Schiff's reagent. That medium is not enough to convert first to cyclic form into open chain form. That is why there is no reaction of glucose with Schiff's reagent. But react with the Tollen's and Benedict's because they contains required amount of medium. So, what is meaning of enolization? Let us take mechanism of enolization. C double bond O, CH2OH is called fructose. A remaining constant only. If first two carbons only participate in the mechanism. These two only. So what is the reaction of ionization means? This hydrogen will form here double bond, then this is taken by oxygen to form C double bond C, single bond OH, one more H is there here, OH, enol, that is new bond, en and ol, enol. Now enol undergoes tautomerization immediately because enol unstable, enol is unstable. So this forms C double bond O and this forms C minus. Is C minus react with H plus N. CH double bond O, CHOH is called aldehyde group or glucose. Okay, so that is why fructose is enolizing in the corresponding medium. That medium is called basic medium. Takes place in both medium, acidic medium also in the basic medium, but required amount is for this inhalation is essential. That is sufficient amount of basic medium or acidic medium is essential for the ionization. That is possible only for the tollens and Benedict solutions. So okay, now this forms aldehyde. This aldehyde now react with tollens reagent. Okay, so statement 1 correct. Statement 2, in the presence of base, that is base, fructose undergoes rearrangement to give inhalation. Rearrangement is also called enolization. Also called enolization or tautomerization, anyone is same, into glucose. Both are true statements and correct explanation also. Right? Next, 2.8 into 10 raised to minus 3 moles of carbon dioxide is left remaining after removal of 10 raised 21 molecules of it from X milligrams of the parent compound or source. The mass of the CO2 taken initially. That means removed amount plus balance amount, sum is equal to initial amount. This model question also in our material also. Same type question. First we convert into mass. 2.8 into 10 raised to minus 3 moles is equal to 2.8 10 raised to minus 3 into 44 grams. But milligrams requirement into 10 raised to minus 3 milligrams. 1 gram minus milligrams. Sorry, gram into 10 raised to 3, 1000 milligrams. So this is cancelled. 2.8 into 4.44 grams. That gives nearly 123.2 milligrams. Next, these molecules also into milligrams. Mass of 10 raised to 21 molecules is equal to 10 raised to 21 by 6.02 10 raised to 23 is called number of moles. number of moles into 44 grams into 10 raised to 3 milligrams. Okay. So 23. This is 24. 21, 24. 10 remaining. Okay. So get cancelled, that gives 73 nearly. 73 milligrams. So 73 plus 123.2. Therefore, total mass is equal to 123.2 plus 73. 196.2 milligrams. Option 1 is the initial amount present. Okay. So number of molecules given, converted moles divided by what number gives number of moles. So moles into molar mass 44 grams, milligrams into 1000. Next one. Ice at minus 5 degrees Celsius is heated to become vapor with a temperature of 110 Celsius at the atmospheric pressure. The entropy change associated with this process can be obtained from. So this is phase change type of reaction. Ice at minus 5 degrees Celsius, converting finally vapor at 110 degrees Celsius, more than boiling point. So this is passing through boiling point and freezing point. Boiling point is 100 Celsius, freezing point 0 Celsius. So here 0, 100%. So minus 5 degrees to 0. 0 to 100. 100 to 110. 100 is called boiling point. 0 is called freezing point. Phase change. Solid to liquid. Enthalpy fusion. Phase change. Liquid to vapor. Okay. So how many steps? 1, 2, 3, 4, 5 steps. First step, delta S is equal to minus 5 to 0 degrees. Cp dt by T, because delta S is equal to Q by T. Q at constant pressure is called delta H by T. Delta H equal to NCP delta T by T. Okay. This is phase change. Delta S equal to delta H fusion by freezing point. 273 Kelvin is called freezing point. Or TF. Take symbol as freezing point symbol TF. Next, this step, delta S equal to 0 to 100, same. N 1 mole only, because not going to take 1 mole only. So T1 to T2, Cp dt by T. This Cp of solid state, I said the Cp of liquid state. but question is not having difference. Molar given, so N 1 mole only. Okay. 273 to 300, 373. Next, this one. This is vaporization, phase change. Delta S equal to delta H vaporization by boiling point, 373. So, these two steps are called phase change. This is also phase change. Okay. 1, 2, 3, 4. Next, fifth. Last step. 100 to 110. Delta S equal to T1 to T2 Cp dt by T. 383. Okay. Then, so 5 steps required. So, without verification, just only where is 5 steps present. First option 1, 2, 3, 3 steps only, not correct. Second option 1, 2, 3, 4, 5, 5 steps in the second option. 1, 2, 3, 4, 5 steps. So, option 2. Option 3 not correct. Option 4, 1, 2, 3, 4, 5 steps. But it is wrong. Cp dt by T. So, that is option 2 correct one. N value 1 mole only. So, first one 268 to 273. Second one fusion by temperature of freezing point. Third one evaporation rate. Each step given. This separate given. 273, 373. Last one also separate given. That is 373, 383. CPDT. So, that is equal to option 2 correct one. Just only formulas addition only from minus 5 degrees to 110 degrees Celsius. Okay. Next, d electron configuration for cobalt 2 plus moment is 3.95. 3.95. So, how many unpaired electrons? Mu is equal to 3.95, nearly 4 root of n into n plus 2. Suppose take 2 electrons, 2 into 2 plus 2, root 8. 3 electrons, root 15 equal to nearly 3.95. That means 3 unpaired electrons requirement. So, T2G6 fully filled, only 1 unpaired electron. T2G3, 3 unpaired electrons. T2G5, 5 means 1 unpaired. E2, 2 unpaired, totally 3 unpaired. This is no need. Why? Because octahedral G requirement, only ET given, the tetrahedral. So, now cobalt 2 plus with 3 unpaired electrons, 4s0, 3d7. Normal weak field ligand only. 1, 2, 3, 4, 5, 6, 7. T2C and EC. So 1, 2, 3, 4, 5. E last 2 in the EC. So total 3 unpaired electrons. Here 3 unpaired, but configuration not suitable. That's why this is not correct one, because we want 3d7 configuration. 5 plus 2, 7 electrons requirement. Here only 3 electrons. That's why option 3 correct one, because T2Z. And it is not given as a strong field ligand or weak field ligand. That is not requirement. We want only 3.95. That is 4 unpaired electrons, 3 unpaired electron requirement. So how to produce 3 unpaired electrons? Suppose you take a strong field ligand. What happens here? Strong fielding means 1 electron go to pairing here. Then only 1 unpaired electron. But we want 3 unpaired. That's why taken as weak field ligand effect only, as it is configuration, parent configuration 3d7. 1, 2, 3, 4, 5, 6, 7. So here 1 unpaired, here 2 unpaired, totally 3 unpaired electrons. Option 3 correct one. Facial meridional A3 B3 type. M A3 B3 type. Option 1. A3 B3 type, minimum 3 requirement. A3 B2C also correct one. A3 B2C also correct one. A3 B2C also correct one. Or A3 BCD also correct one. A3 one set requirement. So here A3 B3. Next, major product of the reaction is CH3, CH2, CHO plus excess of formaldehyde, alkali and reflux. Means sufficient heating is also followed, refluxing. CH3, CH2, CHO plus formaldehyde. Formaldehyde no alpha C. It must act as nucleophile only. It is electrophile. So this is alpha carbon. To form C minus. Is C minus joined with the carbon and O minus in basic medium. That is called Aldol reaction. Not condensation, first reaction, Aldol reaction. CH3, CH, CHO, new bond is CH2OH. Number of alpha H equal number of aldol reactions. Number of alpha H equal to number of aldol reactions. So parent compound has 2 alpha H. So one more step possible. This is one more H. So second formaldehyde, same mechanism to form second aldol reaction. CH2OH, CHO. Last step alpha H finished. Next slight heating following to form Canadian reaction. Because without alpha H undergoes Canadian reaction in the basic medium. This is aldehyde, formaldehyde, because excess given. So both of them do not have alpha H. But out of these two, aldehyde, formaldehyde more reactive. This must undergo oxidation. This will undergo reduction. So formaldehyde undergoes oxidation, formic salt. Suppose NaOH base. And this is reduction into alcohol. CH3, CH2OH, CH2OH, CH2OH. So finally, these two products. This name of reaction is called Tollen's reaction. Tollen's reaction. Tollen's reaction means one molecule is formaldehyde, one molecule is other aldehyde with alpha H. Excess of formaldehyde and other aldehyde with excess of alpha H, more number of alpha H. Means maybe 2 or 3. This previous question, a question will given CH3CHO, CH3CHO, 3 alpha H, 3 steps reaction of aldol, last step conjugate reaction. See, last step conjugate reaction, this aldehyde is without alpha H, this aldehyde without alpha H. But out of these two, formaldehyde most reactive, that will undergo oxidation, this will undergo reduction. Therefore, we want HCO in a correct one, but not there. We want only reduction compound. Reduction compound is this compound. CH3, CH2OH, CH2OH, CH2OH. Okay. So, name of reaction is Tollen's reaction. This is not in the textbook name reaction, but connecting to aldol condensation and also conjugate reactions. Next, correct stability order of the following species. Just check the 4n plus 2 pi rule first. So, this anti-aromatic, minus means 2 electrons, 1 pi bond, total 4 electrons. This is 4n plus 2 rule, 6, because negative charge means 2 electrons, total 6, n is equal to 1, is called aromatic. If fourth one is a special example, actually 4n is equal to 8 electrons, 4 pi bonds, n is equal to 2, it is category wise belongs to anti-aromatic, category wise, but not anti-aromatic. It is non-planar and non-aromatic compound due to tub shape. What tub shape means like this. This is called cyclooctatetraene. So, this compound is non-planar. Non-planar is always non-aromatic. Stability order is called, stability order is aromatic is more stable than non-aromatic, last place only anti-aromatic. So, Q more than R more than P. Okay. Next, propane molecule on chlorination under photochemical condition gives 2 dichloro products X and Y. Among them, X is optically active molecule. How many trichloro products? Only structural isomers for trichloro products obtained from X on further treatment of chlorine with the photochemical condition. So, propane CH3 CH2 CH3 propane on chlorination under photochemical condition 2 dichloro products. Actually, it is not only 2, many products possible, dichloro products. But here restriction statement to be follow. Chlorination means maybe some mono, some di, but he given diluent 2 compounds given. So, take suppose di products. Di means dichloro products. Dichloro takes place like this. Both Cl on the same carbon, both Cl on the same carbon at center plus vicinal plus alternate. So this many products, 1 to 4 products possible, but we want to the statement to 2 dichloro products. So out of these four, any 2 products, among them select optically active. So chiral center requirement. This carbon is called chiral carbon. So write full formula: CH2Cl, CHCl and CH3. So this carbon is called chiral carbon, optically active, because this is CHCl, HCl methyl group. Okay. Now this compound again monochloro to form trichloro products, but again addition of chlorine. How many products possible? Only structural products. So here one possibility present, here one present, because here is H present. So wherever H present, that will undergo substitution. So 3 products: CH, ClCl, CHCl, CH3. Center: CH2Cl, CClCl, CH3. Next one, last one, CH2Cl, CHCl, CH2Cl. So 3 products possible. So don't take stereochemistry, only structural isomers. So how many possible? 3 possible. Okay, option 3, that is 4. Next one, amount of bromine required to convert 2 grams phenol into 2,4,6 tribromophenol. This is one previous question only. So these almost all questions, many questions are repeated questions, models previously, 21, 22 main questions, so just slightly modification given. Now, phenol plus bromine, water, gives 2,4,6 tribromophenol. What is the amount of bromine requirement with phenol? Stoichiometry: 1 mole phenol, 3 mole bromine. 1 mole mass of phenol, 78 plus 16, 88 plus 94 grams. 3 mole bromine, 3 into 1 bromine, 160. Grams. So 94 grams is equal to 3 into 160 grams. Then 2 grams react with, therefore 2 grams react with 3 into 160 by 94 into 2. Gives around 10.22. Okay. So that is stoichiometry only. Next, which are the following set with the same color in the following? There is no mechanism to find out the color, particular color. We can give reason only for the color formation or color not present. That is, presence of unpaired electrons will give color of the compound due to DD transition. But a list of colors in the D block chapter given, that is memorize only. The question is asked from textbook itself. They will never ask out of textbook. So try to memorize the list of colors given in the D block elements chapter, color of the ions. Vanadium plus 2, chromium plus 3, Mn3 plus all these 3 violet color. Follow textbook colors only. Don't take other books. That means in other books given are different colors given. For example, chromium in other books given green given, but NCERT given violet. That's follow NCERT wise only. Vanadium 2 plus violet, Cr3 plus violet, Mn3 plus violet. Okay, option 1. Next, Lessons test covalent organic molecules transformed into ionic compounds. Correct one. Soluble ionic compounds also or ionic compounds. This is also taken correct full form. Soluble ionic compounds or simply ionic compounds. Correct one. Statement 2. Sodium fusion extract of an organic compound having N and S both gives blood red color but not Prussian blue. Prussian blue only for nitrogen but not sulfur. So N and S gives blood red with ferrichloride FeCl3. So statement 2 wrong. So no confusion here, directly clearly given. So 1 false, 2 correct. Sorry, 1 correct, 2 false. 1 correct, 2 false. Next, which of the following happens when NH4OH is added gradually to solution containing 1 molar A2 plus 1 molar B3 plus Ks value is given. That means check the condition of precipitation. Precipitation condition is QSP must be greater than KSP. First compound low AOH twice. AOH twice means A plus 2 and 2OH minus ions. So how to write QSP? A plus 2 concentration into OH minus whole square greater than KSP. KSP 9 into 10 raised to minus 10. A plus 2 given 1 molar. Therefore, 1 into OH minus ion whole square is greater than 10 raised to minus 10. OH minus ions must be greater than square root, 3 into 10 raised to minus 5. Same comparison for second compound. Second compound is BOH thrice, means 1 cation B3 plus 3 hydroxide ions. So write QSP B3 plus OH minus whole cube greater than KSP 27 into 10 raised to minus 18. So it's 1 molar only. OH minus thrice 27 minus 18. Therefore, OH minus ion concentration requirement is cube root 3 cube into 10 raised to minus 18. So 3 cancel, minus 6. So minus 5 minus 6, minus 6 low value. So small amount requirement to first precipitation takes place. So this is small amount. So BOH thrice will PPT form first, then AOH twice. Okay. Next one, molecules obeying octet rule. 8 electrons. CCl4, CO2, because CO2, C double bond O, 8 electrons present. So A4. Molecules with incomplete octet deficiency. 3 bonds only. 3 bonds means 3 into 2, 6 electrons. 3 bonds, 3 into 2, 6 electrons. B2. Odd electrons, NO1, NO2. The odd electrons easy to find out, just adding total valence electrons. So odd number is odd electrons only. NO 5 plus 6, 11, odd number. NO2 5 plus 12, 17, odd number. That's why odd valence electrons becomes odd electron bond only. Molecules expanded octet. Sulfuric PCl5. Because sulfuric is yes, double bond O, OH, OH. One sulfur forms how many bonds? 6 bonds, 6 into 2. 12 electrons. PCl5, 5 bonds, 5 into 2, 10 electrons. So, A4, B2, C1, D3. Option 1. Hinsberg reagent reacting with secondary and primary amines, not with tertiary amines, because NH2 requirement, at least one H requirement, R3N lo no hydrogen, no hydrogen atom, that's why no reaction. So only secondary and primary amines reacting. Secondary, primary, tertiary, primary, tertiary, secondary, ACE reacting. Okay. Next, 1 millimolar solution of ethylamine produces pH 9. Then ionization constant Kb for ethylamine is 10 raised minus x, value of K. So here condition 1, degree of ionization of ethylamine is negligible with respect to 1. Means 1 minus x is taken as 1. That means direct formula can apply. We can know already for weak bases. For weak bases, OH minus ion is equal to root CKB. For weak acids, root CKA. For weak base, root CKB. pH 9, then pOH equal to 5. OH minus answer 10 raised to minus 5. C, millimolar 10 raised to minus 3 molar. Kb find out. So minus 10 is equal to minus 3 into Kb. So Kb 10 raised to minus 7. So direct formula directly, that is Ostwald's formula, OH minus ion equal root CKB for weak bases. Weak acid H plus equal root CKA. Next, during sulfur estimation, 160 milligrams of organic compound give 466 milligrams of barium sulfate percentage of sulfur. Direct formula of Carrier's method, percentage of sulfur equal to 32 by 233 mass of barium sulfate, mass of compound into 100. 32 by 233, barium sulfate mass 466, 10 raised to minus 3 grams. Compound mass 160, 10 raised to minus 3 into 100. Direct cancel. One time, 2 times. 16 one time, 2 times is equal to 40%. Direct formula only, no confusion. Next, sequence of steps given, methyl and nitro, that is called metanitrotoluene. Metanitrotoluene on bromination. This is with respect to methyl group. Methyl is activating at ortho and para. Ortho, para. So we can take better ortho because NO2 strong withdrawing effect. That's why distance increasing, withdrawing effect decreases. Therefore, here better one. Here also possible, para also possible, but this is major amount slightly. But answer is same only. You can take any amount because we want only mass of the compound. Maybe bromine here or here, isomeric form. First step. Second step is reduction of nitro branch with SnHCl. Nitro branch reduction gives aniline. These are not disturbed. Third step, diazotization, diazono salt. Next step, H3PO2. Elimination of nitrogen. To form bromotoluene. Bromotoluene. So, what is the molar mass of A? Final compound. Is final compound. So, this final compound, molar mass of A, 6 carbons, 7 carbons. That is homolog of benzene. Benzene 78. 78 plus 14. 78 plus 14. 78, 88, 92. 92. Bromine attachment by replacement of one hydrogen. So, 91 plus bromine 80. 171. Okay. So, steps important. First one is called bromination at ortho para. You can take para also, no problem. Answer is same only. Bromo. Next one, nitro reduction into NH2. Next, diazotization, N2Cl. H3PO2 lo N2Cl elimination to form benzene. Therefore, bromo branched toluene is the final compound. Okay. Thermal decomposition of N2O5 at constant volume. Following table, 2 N2O5, 2 N2O4 plus O2, 0 initial 0.6, final 100 X, X equal to 10 raised minus 3 atm dash. Rate constant of the reaction is, here small confusion is, rate constant of the reaction is not given as a rate constant of first order. Unit is first order only. That means this condition actually rate constant of reaction K by 2. E2 is coefficient. Ek first order constant. So, K first order constant equal to rate constant of reaction into 2 times, because coefficient is given 2. Because the question given for this equation for this constant means the rate constant of reaction given, but small change the answer. So, if you take this concept, K is equal to 2.303 by T log A by A minus X assume for 1 mole selection, 2 moles correct, no problem, 1 mole easy method. 1 mole, 1 mole, 1 by 2 moles. So 0.6 minus x, x by 2 for 1 mole. 0.6 minus x, x by 2. K is taken Kr into 2. Rate constant of reaction 2.303 by time 100 log 0.6 by 0.6 minus x. Kr given 4.606. 2 into 4.606 10 raised to minus 2. 2.303 by 100 log 0.6 by 0.6 minus x. So already cancel 2.303, 2 times cancel 4. Antilog of 4, 10 raised to 4. 0.6 by 0.6 minus x. So 10 raised to 4 into 0.6 minus 10 raised to 4x is equal to 0.6. Take common term 4. 0.6 minus x so this gives x value nearly 0.5999 x value, but we want to find out the total pressure x. So 0.6 plus x cancel, x by 2. So total pressure point 0.6 plus x by 2, 0.6 plus 0.5999 by 2 nearly gives 8,999. 899.9, 10 raised to minus 3. 899.9 or 900 is correct value. 900 into 10 raised minus 3. So 900. Suppose you take direct rate constant only, this one. If K is taken as first order constant directly 4.606 10 raised to minus 2. E 2x are not there, then log 2, that is 2 is equal to log 0.6 by 0.6 minus x. 100 is equal to 0.6 by 0.6 minus x. On solving this x value gives 0.594. So solve here on a simple one only. 0.660 minus 100x is equal to 0.6. 100x equal to 60 minus 0.6 means 59.4. X equal to 0.594. 0.594. Therefore, total pressure 0.6 plus x by 2, 0.6 plus 0.594 by 2, 0.594 by 2, 0.297, 0.6 plus 0.297, 0.897, 897 into 10 raised minus 3, 897 into 10 raised minus 3. So they given 897. So now confusion is 900, answer 897 means NCRT given as this one rate constant of this question given as rate constant of reaction only, not your first order reaction, but coefficient given 2 moles here. That is why in the previous year question they taken with 2 moles, that is as a rate constant of reaction is equal to 2 Kr as first order constant. 2 Kr is first order constant. But that is just last before your question only, advanced question. They given 2 taken in the consideration as 2K as first order constant. But in this year, this question is not specified about the conditions. So that is small mistake here. So actually answer 900 correct or 897 correct. Small difference. But they given 897 answer, I think. This one given answer. Means they taken as this value is a first order rate constant directly. But why this is more taken as correct means the unit are the important one. Rate constant unit is given as per second. That's why taken directly. This value is taken as first order constant only. So applying this method gives answer 897 is the correct answer. Okay, that means here 4 antilog of 4 10 raised 4. Here 2 antilog of 2 10 square. That is 100. That is difference only. Next, standard enthalpy and standard entropy, both of the compound given. Standard free energy change for reaction is, so reaction only that formula only, because both entropy enthalpy given. Delta Z naught is equal to delta H naught minus T delta S naught. Delta H naught standard enthalpy 55 kilojoule, this is joule, so convert to joules, 55 into 1000 joules minus 298 into 175, 290 into 175, 52150. Two 850. Joule only, same joules per mole. That is the final value. Okay. So in this paper, almost all simple questions only, just to accept 2 examples. So one is called chemical kinetic question, or they just not given first order constant. So taken as first order constant direct itself, because they given as rate constant of reaction, but unit important per second given, taken first order constant. So 2 no need to take, because we are confused about the previous PY question last before year, they taken as 2K as first order constant value given. Same type question given, they given the general method given 2A plus B, like that given. But in compound given 2N2O5. Anything is stoichiometric coefficient is 2 given. That is confusion here, that previous question. So in this question, it is taken as per second, that's taken as direct first order constant itself. That is log 2, antilog of 2 becomes 100. 897 is the answer, integer answer. This one small difficulty in the calculation, means confusion. If you take direct first order constant, no confusion. Calculation simple only, confusion not there. But the confusion only about the taken into 2, not taken into 2, the only confusion. So follow per second taken as first order constant directly. And one more is phase transition, entropy change for the transition from the minus 5 degrees to 110 degrees centigrade. That is just one formula application only. Just 2-3 questions only, small difficulty, remaining almost average level questions or below average level questions. Okay. So any any condition, any value, follow NCERT values only, NCERT textbook values only. Don't follow other examples. So maximum they give any question given from textbook itself only, color of the compound or any value of the compound like bond angle, they from the textbook itself. If they're not in textbook, they never give questions. That is, what is color of the compound, which is not covered in textbook. That's why no need to read about the colors of the compound from other books. That is JEE other books. So that is only JEE other books different requirement for concept purpose only, but not color of the compounds. Colors, bond angles, bond length values for textbook values only. All compounds. Okay. Thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.